And now, Wael Aboulezz, Director of Data Science and Engineering and Analytics at Breadfast, will take the stage with Hypothesis to Impact, mastering the art and science of controlled experiments. From tech giants to startups, data experimentation drives innovation. Wael will show how controlled experiments reveal surprising truth and help organizations make better decisions faster. Please welcome Wael Aboulezz.
Okay, hello. I'm Wael Aboulezz, and I'm happy to be with you all today. I would like to start briefing about the session today. We're going to talk about experimentation. Experimentation is from the practice of many companies. It's a very essential practice in data analytics and data science, for sure. Okay. So why we do experimentation? So I'd like to start with if any of you have previously seen a situation where you had a very clear idea that will improve your business performance or business metrics, and it turned out to be not as successful as you expected. So this is the main reason why we do experimentation in most of the corporate startups and all business applications. Let's start with some reality check. So even the most successful tech companies in the world, like Microsoft, Slack, Netflix, all of them, they actually admit that only around different statistics for different companies, but the range is that only around 20 to 30% of their ideas are proven to be successful and achieve what they are meant to achieve before developing the feature itself. So this is a very, intuitively, this is a very low percentage that you might expect that it should be higher. Actually, no. Getting only 20 to 30% who achieve a very big business impact is already a gain for the company. So the gain here is not about a successful idea that turns out to be giving us more revenue, for example, or saving us more costs. This is definitely a gain. And another gain is actually learning why feature X didn't work and why feature Y actually worked. So this is a very essential component of shipping any feature in any business. Okay, can you hear me well? All right. Okay. Okay. So how will we take the decision of shipping any product feature if we don't experiment it, or if we don't actually test it versus the current status? Okay. So if we don't use data, we are not going to be moving with confidence. We will be moving with assumptions and gut feelings. So why data actually should guide our decision making? It looks very obvious that data should guide our decision making, but why? Because actually, if you are enhancing a specific metric, let's say revenue, user conversion, and you are not following any data-driven study, and you assume that whatever change you make is actually achieving this enhancement, and let's imagine you are planning to do further enhancement by further developing another feature. So it's very obvious that what you can't measure, you can't improve. So primarily, you started following your gut feelings. You started assuming that I will develop feature X and this will get me more revenue, but you can't quantify. You can't quantify how much more revenue actually you got from this feature. Also, you can't assume that this feature was the main reason for this revenue, because it's very dynamic space where we have a lot of changes happening, like seasonal patterns, for example. So we are in a e-commerce application. And there is seasonal pattern where, for example, we have peak of sales every Ramadan. Every year, in the month of Ramadan, we get peak of sales. And then you implement a change just before Ramadan, and you see the revenue is increasing, and you assume that's because of this change. It doesn't have to do with your change or your recent change. Also, you should, the main value of experimentation based on data is that it adapts the culture of learning in the organization. As any organization scale, it has more employees and more decision makers. So each one of them has an idea, and this is very healthy. It's not a bad thing. We should have different points of views and different ideas within the organization. But which idea actually is the best, and which idea will achieve what we are looking for? So this is another value of experimentation, is we will test all the ideas against each other and against the current status, and we will apply a lot of statistical methods that we might have the time to talk about today to actually make sure which idea of them is the best for the business. So it turned from a point of view or an assumption to a data-driven decision that's everyone is aligned about. What's the first step in order to build your experiment? Or you have now 2 ideas that you want to test, and what's the first step you should have? The first thing is actually a good experiment should have very clear hypothesis. So for example, when we, in ads business, for example, when we put targeted ads, we will achieve more revenue or better user conversion. Okay. This is a hypothesis. Maybe the example is a bit clear for everyone. Targeting achieves more revenue or more conversion, but at the end of the day, it's a hypothesis. It can be applied also on 2 different targeting strategies. So for example, I am the director of marketing, and I want to target my ads based on gender, and I have the director of product, and he wants to do the targeting based on other demographic variable like socioeconomic status or something. And each one of us actually claims that his targeting strategy will achieve more conversion, more revenue to the company. And who knows who is right, except if we do experimentation, we start actually testing the hypothesis of each one of us. So how the hypothesis testing works, we will start with the famous one, the frequentist approach, where we will assume that we will have no effect for any feature. So any feature, any new feature, in hypothesis testing, we start by something called the null hypothesis. In this null hypothesis, we assume that no effect. Nothing will change, okay? And in the alternative hypothesis, each null hypothesis has an alternate hypothesis. In the alternate hypothesis, we assume that the feature will achieve the desired outcome and the desired revenue. And we will apply the rest of the steps of hypothesis testing in order to test the alternative hypothesis and understand actually if it achieves, if we will be able to reject the null. Reject the null is the term used to say that this feature actually achieved what we want to look. So for example, if we start targeting our ads by gender, we will achieve more revenue than untargeting our ads. So okay. So we'll start to do the setup. The setup is simply that we will split our traffic, our users, into 2 groups, the A group and the B group. The A group actually sees the untargeted ad. So let's assume that we are targeting by gender. So for the A group, I'm going to see an advertisement that doesn't relate to my gender. It's a random. If I'm male, I can see an ad for male product or female product or neutral product, while in the treatment group, they will see targeted ads, okay? So if it's a gender attribute, so you will see that, for example, male-related SKUs or male-related products will be shown to male customers or male users, and vice versa for sure. This is an online experiment because actually all our users are using the application and all our users are split into either A or B. And then we will measure The conversion. So let's say we are interested in user conversion, and we will start checking how much conversion did we reach from each group, from the A group and the B group, online. One of the very famous approaches to identify the performance of each group is the statistical significance. And this is simply put into English, is actually, it's just how, if we, let's say the targeted group conversion is 40%, the untargeted group conversion is 30%. How can we tell that this 10% difference is actually not random variation, not due to chance? In other words, if we repeated this experiment 1,000 times, what's the probability that we will observe this difference each time? That it's not happening randomly, okay? So the p-value answers the question of what is the probability that we observe the data we are observing now, given that no effect, that targeting doesn't increase conversion in our example, okay? If this probability intuitively is very, very low, so we say that we should actually believe that targeting will increase conversion because it's very low probability that we will achieve this difference randomly. This low and high is very common for business applications to be 5%. I'm sure you are familiar with the significance level of 95%. So the p-value here plays the role of stating that if we do this experiment 100 times, and you will probably find consistent results 95 out of them, or 950 out of 1,000, or as you scale the experiment, okay? So there is a 5% still error. So when we do experimentation, and we want to be accurate with the business, we say that we are confident 95% that this change achieves what you are looking for. So what if the business told you, no, I need to be 100% that this feature achieves the desired outcome. That if you do targeting, you will get more revenue. Okay. 100% because for him, he wants to be very sure, and he says that 95 is not enough. I want to be 100% sure. So if you get 100% confidence in your hypothesis testing, this comes at cost. It's not. There is nothing for free. So when you increase that significance level to 100%, you are reducing the other side, the power. The statistical power is the trade-off here. When we increase significance too much in order to be very sure about our changes, this comes at the cost of missing a truly impactful feature, because you might have another feature that truly impacts your business, but you want to be very, very, very sure, so you start waiting for getting the 100%, and it never comes, so you miss actually a very, very impactful feature. So it's harmful sometimes to increase significance level. Also decreasing it a lot in order to be very sensitive to impactful features and detect it easily will also come at cost, because you will not be that confident in your change. So there is always a trade-off, and the famous setup for most of the business applications is 5% significance with 80% power, but these values can change, and you as a data analyst, you have full control to change the significance level and the statistical power that you are looking for. You just need to understand which is more costly to the business. Missing an impactful feature. By missing, I mean that you tell the business it's not achieving what you are looking for, and truly it achieves. Or the other way, moving with a feature that is not impacting any business metric, but you assume that it has impact. Okay? So this is one trade-off. Another thing is, what if you actually do the experiment and you start concluding that it's statistically significant and we should implement this change. So for each user on our application, we should show a targeted ad that we will see this user's demographic variables, and we will display the relevant ad to him, because we proved that this is achieving higher revenue. How much higher? So let's assume that in order to do targeting ads, we develop a customer segmentation model. We go to the data science team, please develop a customer segmentation model in order to target our users on the application. So this is a development effort that costs the company some costs. And we start deploying this customer segmentation model on our environments, and this will cost us also infrastructure costs and other costs. So we do all of this in order to achieve higher revenue. But how much higher? Let's assume that the experiment achieves 2% higher revenue. 2% higher revenue differs from company to company. So here comes the term called practical significance. Practical significance is a term used by the business in order to achieve what's meaningful for them. Let's assume that I want to achieve at least 3% higher revenue to justify all the targeting efforts I'm doing now in order to do targeting ads. Okay? Otherwise, I won't need targeting. I will proceed with random because the difference is only 1%. And 1% is not meaningful for us. For sure, it's very clear that as the company grows, as the revenue, as the top line increases in any business, 1% is a big thing. So the percentage here is not the point. The point is that we have certain practical significance that we calculate or we take from the business that tells us what is a minimum required effect for this feature in order to move forward. So this actually the trade-off we are just talking about, where you will have here certain point for frequent approach. You will have a certain point. If you achieve higher conversion, you will move with alternative hypothesis. Alternative here, we mean it's better for the business. We will do target. Null hypothesis, it doesn't differ. We will not do target. We will, in the frequency approach, we start with a certain critical point of conversion. If we achieve more, we will assume we are with the orange. If we achieve less, we will assume we are with the blue. You can see here, there is an overlap between both. So there is this triangle is actually after the critical point, so you assume that targeting is doing the right thing. But this triangle actually under the blue curve, which means the null hypothesis. So you have this amount of risk. This here, the 5% we were talking about. So the 5% risk here is actually the amount of risk I'm carrying by moving forward with a feature, implementing a feature, thinking that it will achieve its impact, but it doesn't. Here it comes. Vice versa, statistical power is the blue triangle. Okay. Sometimes it's one final note here on this curve. The practical significance we were talking about is actually the distance between both distributions. So if you are looking to increase the practical significance, this will mean less overlap between both distributions. Okay? Intuitively in English, if the business says, if any feature achieves less than 100% extra revenue, I will not implement it. This is a very big percentage that probably will make us not very risky. It's very easy to detect a 200% change. It's very hard to detect a 0.5% change. As the practical significance gets smaller, as the risk increases, and actually it's very hard, and it requires more data and more samples in order to test our hypothesis. Another methodology is the Bayesian approach. The Bayesian approach starts with the previous knowledge of the company. So we know before conducting the experiment that we have around 4% conversion on our ads. And we start updating these distributions by developing both variants. And we start asking ourselves, what's the probability of having a successful alternative hypothesis given the data that we have? Okay? It's a lot It's a big topic. I'll just pass quickly. So we have two approaches of measurement, the frequency approach and the Bayesian approach. What I care for is the interpretation. For the frequency approach, we are calculating what is the probability of observing the data we are observing now, given that there is no true effect between both features. For the Bayesian approach, what is the probability of a successful hypothesis given the data that we observe? So it's a different question that has a different answer. Okay. We said that we will observe the p-value in the frequency approach, and if we have less than 5%, we will assume that this feature is successful. Okay? This p-value actually fluctuates. So you need to be very, very careful when you will look at the p-value. Versus the Bayesian, it's not like that. So in the frequency approach, you should look only after achieving sample size. If you look at the p-value every now and then, you might observe fluctuation in p-value below the 5%, and you start assuming that you have an impact while you don't. So it's a problem called peaking in statistical significance. Okay? So it's one of the cons of the frequency approach is that p-values misunderstood due to fluctuation. So be careful if you are a data analyst. Also, if you are a product manager, you should also check this point. Okay, how we'll design our experiment? Let's take the targeting example. So we have the first thing is we should start with a very clear hypothesis. What's our hypothesis? Our hypothesis is targeting ads will increase user conversion and consequently revenue. So this is the hypothesis. What's the randomization unit? How we will split our treatment and control groups. In our case, we will split based on users. So we'll take some users here and some users there. So the randomization unit is most commonly users. Okay, what is the targeted population? Who will actually be the population of this experiment? So it's our users in a specific area or in a specific business vertical. Okay, and how large our experiment needs to be. So as I said before, smaller changes are harder to detect. So if you are looking for an 0.01% increase in revenue as a practical significance, this means that you need more data and more samples in order to be sure that you achieve this small change. Okay? As we gave an example also previously, the seasonality factors. We know that weekends, specific month of the year, already have Christmas, Ramadan. All of these are impacting our numbers. So we need to be very, very sure that we take care of this in the experiment duration. Seasonality. Okay. After the experiment is run and we do the setup, we will start doing the interpretation. So we'll start checking if we have right instrumentation, we have the right data logged, everything is working fine. What is the practical significance? What is, if you are using frequency approach, what is the statistical significance, and whether to move forward with the feature or not. Okay? Moving very fast on the maturity model. So here the companies, they start with basic experimentation. They do very few experiments. They do just, these numbers are not based on, they are just based on practice, but it can vary from company to company. So let's say we do then less than experiments per year. This is a very beginner stage. After that, you start walking. You have standard metrics. You know everything in AA testing. It's a technique to figure out technical issues. And you do quality checks, and you do 50 experiments per year. After that, running, and after that, flying. Like all the big tech companies, they are do thousands of experiments per year. Thousands of experiments, thousands of ideas. Okay, so these are the steps we were talking about. You should start with a clear hypothesis, define success, randomly assign users, avoid peaking, check invariance, account for seasonality, and validate your data. Okay, common pitfall, frequency. Don't look at the p-value very early. It should misguide you. It can give you incorrect decisions sometimes. Okay. So regarding to the culture, what are the 3 pillars of an experimentation culture? We should democratize experimentation. Everyone has the right to experiment. Every idea has to be tested. we should celebrate learning over winning. We don't actually need to win every time we have an idea and prove that it achieved the business outcome. It's very enough that we know that it doesn't. So we should celebrate learning over winning. We should reward curiosity and testing mindset. Every idea has to be tested. Okay? And the third very important pillar is how to make it easy to test. Here is the technical work. You need to build the infrastructure for everyone to be able to test his idea and able to see the results, whether it wins, it loses. As we said, in all cases we learn what is actually truly impactful for the business. We can use methods like Victor, Weather, Dufos, and Breeze. These are softwares and tools to allow us to do very cheap experiments with very low effort to understand if it's impactful, and we then go with the development and the big effort. Okay, so I'm open for your questions. Thank you.
Yes. Thank you. I have a question. I'll start with the funny quote and well, it might make you hurt inside. I joined the data science team once and they were about to do some A/B tests. What's the metric? We'll run the test and figure that out. And I just what am I going to something to? But it kind of does tap into the question, which is that obviously we want to have a test where we've got a great P value, we know we've got enough power, we're happy with all these things, but sometimes that's not possible because, for example, the managers aren't willing to let you trial on enough data or like a big enough potential risk experience. So in order to get a result with a significant power, it would take too long, so you have to cut corners. So pragmatically speaking, have you experienced any tips for when you cannot do it? It's not going to work to run a proper test because it will take 6 weeks or something. And you probably can't make a heuristic of, well, it's better to just have wiggle room on your p-value or your power because it's going to depend. But have you had any experiences with how to pragmatically do it right?
Yes, very frequent thing. And actually, one of the things that helps with reaching a decision a bit earlier is actually, from my point of view, is actually using a Bayesian approach for measurement rather than a frequency approach, because this allows you, I have heard an analogy that I like it a lot. Bayesian approach is like you are baking a cake and you are checking the oven every now and then to see if it's done or not. The frequency approach is that you read in the recipe, you have to leave it for 30 minutes, and you don't touch it. When the timer stops, you get the cake out. It might not be ready yet, it might be burnt already, but you have to wait for it. So, in order to get the results early, if the problem is time, Bayesian approach will help. But if we even don't have the time for testing it, so it depends on the cost of development. I wouldn't assume that developing a very costly feature, let's assume that 50 engineers will work on it for 1 month. This is a very big decision to take by gut feeling. If it's a very, very small effort, okay, we can develop it. And you will be in the gut feelings, but you didn't risk a lot of effort.
From your experience, actually, you presented this.
Well, thank you so much for this presentation. We saw this slide of the difference between big companies, small ones, big companies. You said they run most probably 3 years.
More, yeah.
Great. From your experience, what did they run experiments, provided that they don't have that?
Yeah, we don't have that.
Because of course, even for leaders that we are not taking this amount of time.
Yeah, definitely. So in the very early stages where we don't have enough data and we don't have enough traffic, actually, I like a quote I've read before also that says, let's assume we have a business that has two users. B2C business that has two users. This is just launching 30 minutes ago. And we have two users now. If you develop a very risky feature, you will not lose a lot. If you develop a brilliant feature, you will not gain a lot. Because you don't have that amount of traffic that allows you to as the company scales, you should start with adopting more, investing more in the data pipeline. So as the company scales, you have more users, and consequently you have more data. You have data warehouse, you have data pipelines, you have metrics, you have measurements, you have everything. So as the company scales, traffic increases, and here the risk comes. When the company starts to scale, a single mistake can get us loses millions of dollars. A single win can achieve millions of dollars. So by scaling a company, we should make sure we had the right systems, we have data warehouse, we have the right metrics, overall numbering infrastructure is working fine. And at this point, you can start experimenting everything because you have more traffic and more data, and you can reach the conclusion within 1 or 2 days. Because let's assume that I have an app that has 10 million users a day, 10 million active users a day. So if I split here control and treatment, I will have 5 million in each group today. So I can tomorrow have enough statistical significance. I hope I answered.
Actually, you opened another area, but I have this case study and let's apply to teachers. I'm going to approach a business today. They don't know anything about the AI. I'm going to tell you that, guys, I'm going to help you with this. Give me, from your position, from your experience, how shall I ask them to give me in order to tell you I have 3 or 4 successful experiments that I will tell you they will benefit.
Okay?
Yeah.
Think it this way.
Yeah,
We
yeah.
need to
Yeah,
get
yeah.
business leaders now to
Start
embrace
embrace
the experimental mindset,
Yeah.
statistical mindset, and they know nothing about it.
Yeah.
I can tell.
Yeah.
So how long shall I ask them? Give me 1 month, 1 month, 4 weeks.
Yeah. If we are able to, yes, I understood the question. We will take time for sure if we are able to collect this data from them. How many active users do you have? Are you a B2C business, first of all? How many active users do you have per day? What are your most brilliant ideas? What's the cost of developing them? And when they answer these questions, we will say, let's have a 6-month period and give you everything. Because I can calculate it. You can calculate that having this amount of active users, having this amount of ideas, we can split the traffic and we can start reaching these decisions. If the amount of time is very big for them, because I know executive, they're always pressuring on them. So this actually can help with classifying the features. We should classify features from development effort perspective and from risk. So this is high risky features. It should be tested. These are less risky features we can go with. And those who should be tested, we can actually start putting the time frame for Bayesian statistics in order to give us the right decision. Thank you. Okay. So that's it. Thank you. Thank you.